right, thanks for joining us. My name is David Hall with National Instruments, and I'm here with Simon Wood from Wolfspeed. And today we're showing a joint demonstration with one of their RF power amplifiers. So Simon, why don't you tell us a little bit about the power amplifier in the demo?
Yeah, sure thing. This is it's a two-stage LDMOS RFIC running at 28 volts, part number PTN C21060. It's a 10-watt average device for massive MIMO small cell deployments in the 1.82 gigahertz, 2.2 gigahertz range.
Perfect. And what are some of the unique features or benefits of this particular amplifier?
So it'll provide about 30 dB of gain, 10 watts average output power with about 50% PAE. Instantaneous bandwidth, 1.8 to 2.2 gigahertz, so being able to take care of multi-carrier aggregation in 4G and sort of massive MIMO type standards for 5G.
Perfect. And in this particular demonstration, we're actually testing it under digital pre-distortion conditions, where we're using software on our system to help linearize the RF power amplifier. So Simon, how does your customer use some of that information, like the linearized condition performance, when you're working with new customers?
So typically a customer engagement, if we're bringing out a new product, they need to know a little bit more than just what's the power, what's the PAE, what's the gain. They really want to understand how is the product going to work in their system. And so we want to be able to demonstrate the performance of the product under digital pre-distortion. And so having an engine like this available for the lab, we're able to demonstrate that system level performance much earlier in the design cycle for the customer before they get to that point in their system design flow.
Perfect. And of course, one of the technical requirements of testing a PA under DPD conditions or linearization conditions is the instantaneous bandwidth required to actually produce that waveform. Most test configurations require that the instrument has somewhere between 3 and 5 times the bandwidth of the signal in question. So in this particular case, we're showing a 2-carrier LTE waveform, and those LTE carriers are spaced at 100 megahertz apart, and that would require 300 to 400 megahertz of instantaneous bandwidth on the instrumentation in order to present that waveform to the device under test. So of course, this particular test configuration is using NI's vector signal transceiver. For more information on the NI system, you can go to ni.com/5G. And of course, you can go to wolfspeed.com/RF to learn more about their full product line for RF devices.
Thank you very much.